this class. My name remain what? Paul Onyema. So you got. Let's start with what? A man on a what? A lift. A man on a what? On a lift. Now there are what? Four cases. We are going to check under what? A man on a lift. Now let's check for what? Case what? Case one. That is when what? The lift is what? Moving upward. Now, when a man is on a lift, we are going to check how many cases. Four cases. Case one is what? When the lift is moving upward. So let's take it to be this. Let's assume that this is the lift, and a man. Let's assume this is the man on what? On this lift. Now, take note now. And this is the rope tied to the what? Lift or elevator. Now, what I want to note is that there are two forces that will act on this man. How many forces? Two forces. Now, the first force that will act on this man is that the weight of this man is going to act what? Downward. Please take note of that. The weight of what? Of this man will act what? Downward. And what is the second force? The second force is the force of this elevator. The force of the floor of this what? Elevator. Now, which is known as what? Force of reaction or what? Tension. Now, where will the force of this what? Or this elevator we act to the man also upward. Let's take note of this case now. There are two forces acting on a man on a lift. The first force is the what? Weight of the man. And the weight of this man we act downward. And the second force is what? Is the force acting on a man on the floor of the elevator. And the force acting on the floor of the elevator acts upward. Now, let me call this force that is acting upward to become what? Tension, T, or reaction. Now, for this lift to move what? Upward, it means that what? The weight of the what? The tension in this case now. So, because this lift is moving upward, please take note now. The tension is greater. What is greater now? The tension is greater than the weight of this man. Why? Because this lift is moving up. Because there are two forces acting on a man on this lift. What are the two forces? Number one is the what? Weight of the what? Of the man. And where is the weight of the man acting? Is acting downward. Now the second force is what? Is the force on the floor of the what? Elevator. And it's called the tension or reaction. And it's acting upward. Now in this case now, for this lift to what? To move upward, it means tension is greater than what? Weight. So there is on what? Unbalanced force. Now, what is that total force? But take note now, this lift is what? Accelerating upward. This is how it moves. Now, what is that the total force acting on this man on this lift? Now, the total force F is equal to, out of these two forces acting on this man on the lift, which of them is acting in this direction? Is the tension. Therefore, tension will act what? Or tension will be what? Positive. Therefore, this is our tension. Now, because the weight of this man is acting downward and is opposite to the what? The direction of the what? This movement. Therefore, the weight becomes what? Negative. And don't forget, let's make what? Tension subject of the formula. So this T is because when this guy cross to this place, because what? F plus weight. And don't forget that force equal to what? Don't forget that force equal to what? MA, and W equal to what? Mg. Now in that case, tension becomes what? Anyway, see F becomes what? MA. So this is our what? MA plus weight is what? Mg. So weight becomes Mg. Now, in this case, if this is the case now, what is common between these places is what? Mass. So therefore, tension equals to what? Mass open bracket what? A plus G. Please don't forget, this is our what? Formula. When the lift is moving upward or accelerating upward. Take a look now. What is our tension now? Our tension equals to what? Mass open bracket what? A plus G close bracket. These are our word formula. Under this case, please take note of something now. Under this case now, take note that what? Tension is greater than weight of the man. The what? The force acting on the floor of the elevator, which is tension or reaction, is greater. Why is it greater? Because for the lift to what? Move upward, it means the tension must be greater than the weight of the man. Now, in this case, take note that what? Because if you want to measure the weight of a man, or when you want to measure the weight of a particular object, we use what? Spring balance. Now, what will the spring balance record? In this case now, the spring balance will record what? The man will appear what? In this case now, the man will appear heavier. Why? Because it's moving what? Upward. Please take note of this case now. Whenever the lift is moving what? Upward, the man appears heavier. Take it now. It appears what? It appears heavier. Please take note of this now. If I'm too fast, you can watch, pause the video and get it very well. Please take note down. What formula are we using when the lift is moving upward? Tension equal to what? M over bracket A plus G close bracket. Now in that case now, the tension is greater than the what? The weight of the man. And in this case, the man appears heavier or bigger. Please take note, this is what? Case 1. Now, in this case now, let's now move to what? Let's move to case 2. Let's move to what? Let's move to case 2. Now, for case 2 is what now? For case 2 now, is when lift is moving what? Downward. That is for case 2. When the lift is moving what? Downward. For case 2 is when the lift is moving downward. Now, please take note of this case now. When the lift is moving downward, so let's take this scenario now. Let's assume that this is the what? Let's assume that this is the what now? This is the lift, and this is the rope tied to the what? To the elevator. Now, if this is the man on this lift, if this is the what? The man on the lift now, because he's moving downward, he's moving what? Downward. If he's moving downward in this case now, it means the weight is bigger or greater than the what? Tension. So this is the weight. Weight acts what? Downward. Please don't forget. Weight always acts downward. Therefore, the tension or the reaction from the floor of the elevator acts upward. Let me call it T in this case now. Take note now. For the lift to move what? Downward. For the lift to move what? Downward. The weight of the man, the weight of the what? Man acts downward, and the weight of the man is greater than the tension. Why? Because the what? Lift or elevator is moving what? Downward. Now, in this case, if this is the case, what is the total force acting on this man? Now, therefore, total force, because take note now, where is this lift moving? It's moving what? Downward. This is the what? It's accelerating what? It's accelerating downward. Now, in this case now, the total force acting on the man on this lift. Now, out of tension and weight, which of these two is moving downward is what? Weight. Therefore, weight will be positive in this case. Therefore, our peak weight will be because it's positive. That is weight. Now, because tension is moving up and the body is moving down, therefore they are opposite direction. So tension becomes negative minus T. And don't forget, let me make T somewhere from now. I'll bring T to this place and take F to this place. So it becomes what? Weight minus force. And don't forget that weight equals to what? Mg. Please don't forget. Weight equals to what? Mg. Weight equals to what? Mg. And force equals to what? Ma. Now in this case now, our tension becomes what? What is our weight equals to what? Mg minus what is our force? Our force equals to what? Ma. Now the same thing, don't forget that what? There's something common in this is what? Mass. So what you factorize, that is you factorize out the mass, open bracket. What are we having here is what? G minus A. Please don't forget. So this is the formula when a man is moving downward on a lift. The formula becomes what? T equals to what? M equals to what? G minus A. In this case, take note that what? The weight of the man is greater than the tension. In this case, please don't forget. The weight of the man is greater than the what? Than the tension. Now, in this case, what will the spring balance record? Now, the man will appear as what? Lighter. In this case now, when the what elevator is moving downward or decelerating, the man it appears what? The man appears, it appears lighter. It appears what? Lighter. When the what? The elevator is moving what? Downward. Please don't forget. That is under what? Case 2. And don't forget our formula for case 2. Rising what? When it's moving downward, T is equal to what? M over bracket what? G minus A. Don't forget. So now, if I'm too fast, please pause the video so you get it better. Now let's move to what? Case 3. Case 3, we are going to check case 3 when the rope of the elevator cuts. That is case 3. Let's move to case 3. Let's check what? Case 3. Let's check case 3. So let's move to case 3. I'll take case 3 to what? When the rope cuts. That is, when it cuts, we call it what? Free fall. Please take note, we call it what? Free fall. When the rope of the elevator cuts, or when the cable of the elevator or lift cuts, we call it what? Free fall. Please take note now, when this takes place, know that A becomes G. Please don't forget, A becomes what? G. Now, in this case, you know that if the rope of this elevator cuts, the elevator will move what? Downward. The elevator will move what? Downward. So, when the elevator is moving downward, it means we're using the formula for what? Case 2. Don't forget. Let me see, draw the elevator. Now, this is how the elevator will look like. So this is the rope of the elevator. So this is the man on the elevator. Because it's moving downward, it means which one will be greater? The weight will always be greater because it's moving downward. This is the weight. And this is what? Tension. Now, when the rope cuts, what happens? It undergoes what? Free fall. Another case now, A equal to G. And I always use what formula? I always use the formula for case 2. Why? Because the lead is moving downward. In that case, now what is the formula for case 2? Case 2 says that what? T equal to what? M over bracket what? G minus A. Now, in that case now, A equal to G in this case now. Therefore, now say that T equal to what? M over bracket G minus. Anyway, see A, take it to what? G minus G. This is now T equal to what now? M into bracket what? 0. So M times 0 because T equal to what? 0. Please take note, in this case now, the weight of the man appear what? Weightless. Please take note now. Whenever you hear the rope of the lift or elevator cut, take note that the weight of the man appears weightless. The weight of the man appears weightless. Take note of that. That is case 3. Take note of that. Now take note of that. It appears what? It appears what? Weightless. Please take note now. When the weight of the man appears weightless, when the rope of the elevator cuts, or when it undergoes free fall, in that case, A becomes G. And what formula are we going to use? Are we going to use the formula for case 2? Why? Because when the rope of this elevator cuts, this elevator will move what? Downward. Now, in that case now, when we see A, put it to the G. And that, in that case now, when we do that, T becomes what? 0. It means the weight of the man appears weightless. Under which case, when the rope of the elevator cuts, the man appears weightless. Please take a note of that. That is under what? Case 3. Now let's move to the last case, which is what? Case 4. Let's move to the last case, which is what? Case 4. Let's move to the last case, which is what? Case 4. Now, case 4, another case 4 is talking about what? When the lift is stationary. When the lift is what? Stationary. Or moving, or what? Or moving at constant velocity. Or moving at what? Constant velocity. Please take note of that. When the lift is stationary or moving at constant speed. Take note of this, please, everybody now. Now, when the what now? In this case now, let's assume this is the elevator. Now this is the rope of the elevator. This is the man on the elevator. Now, let's assume this is the weight of the what man acting downward, and this is the force from the floor of the what elevator acting what upward. Please, in that case, take note for the lift to be stationary or moving at constant speed. Please take note, everybody now. For this lift to be stationary, what will happen? It means the total force acting on the man on this lift are equal. For this elevator to be stationary, and don't forget, there are two forces acting on this man on the lift. What is the first force you have to take note is that the weight of the man, and where is the weight of the man acting? Is always acting downward. And the force on the what floor of this elevator is acting what upward. You call it what reaction R, or you call it tension T. Now, for this man on this lift to be stationary, it means these two forces must be what equal. Now, in that case, now take note of something. Now, when you hear that the body is stationary, it means this man or this elevator is neither what accelerating nor what decelerating, because it says it's what stationary. In that case now, if it is stationary, take note that at constant, or here at constant velocity, take note that A equal to what 0. So when you hear that word that the lift is stationary or is moving at constant velocity, what is 0? Acceleration A is 0. Acceleration A is what 0. Now, if this is the case, now don't forget that A becomes what now 0. Now, because what the lift is what now stationary or at constant velocity. Now, in this case, don't forget that if A equal to 0, because the lift is not is stationary or what is not moving. Now let's pick one of our formula, which is that what T equal to what M over bracket what A plus G. But in this case, our A equal to what 0. If our A equal to 0, this place becomes 0. So, and if this place becomes 0 now, T becomes what in this case now mg. Please don't forget. Don't forget. Because here now, A is what? Our A is 0. So when you put 0 here, you have only G here. So T becomes what? mg. Please don't forget. Or another way you can do it, or because this elevator is stationary, it means tension will be equal to what? Our weight. Because for this lift to be stationary or for it to move at constant velocity, it means A is 0. And at this case, if this lift is not moving, the reaction force or the tension force will be equal to our weight. Therefore, you can just say directly that W equal to what? Weight. And what is equal to weight? And weight equal to what? mg. Please don't forget. Now, in this case now, take a look now. In this case, when the lift is stationary or at moving at constant speed, the tension force and the weight of the man are equal. Now, in this case now, what will the spring balance record? It means it will record the what? The exact weight of the man. The what? The what? It will what? Record the what? Exact or real weight of the man. Please take a look now. When will the spring balance measure or record the exact or real weight of the man is when the lift is stationary or moving at constant speed. Everybody take note of that. When will the spring balance measure or record the true weight or the what exact weight of the man is when the lift is stationary or moving at constant velocity. And take note, in that case now, T becomes mg or T becomes the weight of the man. It means the spring balance, which measures weight of an object, we will measure the what exact weight of the man. So on that case, what now? Case 4, which is what lift is stationary or moving at constant speed. T equal to what? Weight. Please take note of that. Please. Okay. Let's recap. Let's state from those formulas back so you understand it now. Now, case 1. Let's summarize case 1. I think case 1. is when the what lift is moving what upward. In that case now we have that T equal to what now? M over bracket what? A plus G. Please take a look at this what? 1. Where are you going to use this formula? When the lift is moving upward or accelerating.